Good evening, everyone, and we would like to present you a new paper which is called Learning Word Embeddings for Ukrainian, a comparative study of FastText hyperparameters. And for this one, I am joined with the beautiful Nataliia Romanyshyn, who is a Bachelor of Ukrainian Catholic University. Well, let's start with introduction and motivation. While FastText embeddings are here for the last 5 years, they're still widely used. And not only used in production tasks, but also used in research. And if you would like to reproduce some research results from another paper for your language, like we do for Ukrainian language, you would like to have the best possible FastText training embeddings. So we are aiming exactly at this. While FastText CC provides a lot of pre-trained FastText word vectors, those were trained on very noisy data and they was never updated. So we would like to check if providing a better data will have an impact on the intrinsic and extrinsic evaluation. In the current study, we would like to evaluate different changes, different potential options in hyperparameters. To name few, a corpus size, a specific model, CBO versus skipgram, and a set of hyperparameters related to the FastText algorithms. Also, we conduct a proper evaluation and we do both extrinsic and intrinsic and compare it to the existing word embeddings for the Ukrainian language. So to sum up our research goals, identify key hyperparameters, how they affect the results, build a baseline vector models, compare them with the models built using grid search over the hyperparameters, build the pipeline to evaluate both in an intrinsic and extrinsic way, and finally do the evaluation and present our results to you. Also, we did make it 7 servers full, busy for a month, maybe. Let's start with the data. If you search for Ukrainian corpora, which is available online, you might find corpora like Zvidusil or Grag. Both are beautiful products, but unfortunately, they are not available for the download. So for example, you can use them through the corpus manager, but you cannot download text to train your word embeddings. Instead, we would like to use a different approach. We start with 2 versions of the UberText. UberText 1.0 was released back in 2016, and UberText 2.0 was released recently. And for this particular work, we've been using a developer preview. So we can check how the change of the size of the corpus will affect the result. You can see that the difference in the size is roughly 3 times, 2.5, I believe. To work with text, we do some pre-processing steps. First of all, we retrieve the data as it is from the database of the UberText, and we remove all the markdown tags. We fix broken encodings, we normalize text, we fix mixed Latin Cyrillic text, and some other heuristic to make texts cleaner and better. Then we remove all the Russian text or the text where the Russian words dominate the Ukrainian words, which happens in Ukrainian media especially. We then tokenize them into the paragraph, sentences, and words using the language tool and tokenizer for the Ukrainian language. We also do remove the punctuation marks.
Yeah, I will continue with the methodology. So we choose 2 main methods for obtaining context-independent word embeddings. This is continuous back-and-forth CBO and skipgram. CBO model learns to predict a target word based on its context using the sum of the background vectors. And the skipgram model uses the target word for predictions, for predicting the context by summing the log probabilities of the surrounding words to the left and right of the target word. An example of such a language model is word-to-vec, described by Mykolov et al. In 2013. Word2Vec main drawback is that it ignores the word's internal structure that contains rich information that could be beneficial for morphologically rich languages like Ukrainian. Therefore, we choose the FastText implementation of these models. The authors proposed to take word morphology into account by representing each word as a pack of character and gram. They evaluated FastText model on 9 languages, exhibited different morphologies, but Ukrainian was omitted. And later in 2018, Gravital developed and released FastText language models for 157 languages, including Ukrainian, but they did not provide any evaluation of the embeddings for this language. They used Wikipedia, which is of limited diversity and quite noisy data from Common Crawl project. The authors concluded that the quality of the obtained vectors for low resource languages such as Ukrainian is significantly worse than for high resource ones. Therefore, we properly evaluate the proposed by the authors word embeddings for Ukrainian to further compare them with our embeddings trained on the previously presented corpora. Novotny et al. In their paper outlines that one of the FastText hyperparameters named supervised has a significant impact on the accuracy of FastText language models and proposed a simple and gram coverage model. The authors discovered the optimal supervises on the 9 word analogy tasks, and we utilize their findings for Czech and Russian, as they also belong to the Slavic language group. Now let's move to the pipeline of our research. At first, we trained the FastText model on our dataset UberText 2.0 with default hyperparameters, but the vector dimension was fixed to 300 instead of 100. We introduced this model as a baseline. The next step was to tune hyperparameters. We decided to add more epochs for training. By default, the FastText library trains for 5 epochs. Add more negative samples. By default, it is 5. I use different character and gram size instead of default range of from 3 to 6, and utilize the SIBO model for learning word vectors. As the default is a skip gram variant. After that, we decided to investigate the impact of training dataset on the quality of produced vectors. For that, we utilized the smaller corpus, UberText 1.0, and trained models with optimized parameters on intrinsic and extrinsic tasks. The last step is to evaluate the obtained models using intrinsic and extrinsic evaluation methods on 3 different tasks and analyze the impact of various parameters on the results. The evaluation of the word embeddings generally divides into 2 groups, intrinsic and extrinsic. Intrinsic evaluators directly measures the syntactic and semantic relationship between word vectors. For this study, we intrinsically evaluated our models on the word analogy task, also known as analogical reasoning, where in the test set triplet of words are given, and the goal is to find the 4th word. For these tasks, we also developed the word analogy dataset for Ukrainian, which included approximately 24,000 of questions on 12 topics. More precisely, analogy questions are represented by the relations shown in table 3. Extrinsic evaluation measures the contribution of the word vectors to specific downstream tasks. We performed experiments on 2 sequence labeling models, its name entity recognition, and part of speech tagging. We utilize spaCy and Flair modern NLP libraries, as they both support Ukrainian language and usage of custom word embeddings. The dataset for extrinsic evaluation were derived from publicly available GitHub repositories. For the NER task, it was Ukrainian corpus for named entities recognition, and for POS tagging, Ukrainian universal dependency in corpus. Metrics were a FAN score for the NER model and the accuracy for the POS taggers. Now let's move to the results. Table 4 compares the accuracy scores for the baseline model with default hyperparameters and the optimized models for different trained datasets and algorithms. Overall, it can be seen that the optimized skip gram model increases accuracy by 7% compared to the baseline model and by 6% 6.4% compared to the Gravital Ukrainian word embeddings. Models with larger training data generally outperforms models built with Hypertext 1.0. And in terms of architecture selection, the skipgram model shows significantly better results than the SIBO one for the word analogy tasks. We observed minor improvements in the quality of word embeddings for the NER task, and table 6 shows table 5 shows no significant advances, and the F1 scores for different models are roughly the same. Improvements in optimized models for POS tagging tasks also can be considered modest. spaCy POS accuracy showed almost no increase with model optimization. And the accuracy of Flair POS increased by only 2.8% compared to the SIBO baseline. And in general, Gray et al. Embeddings outperforms all of our models for this task. So as we can see, the performance on downstream models is inconsistent across tasks and with intrinsic evaluations. And then Dima will continue with conclusions.
Yeah, thank you, Nataliia. And let's jump to the conclusions. First of all, we identified the key hyperparameters and the effect on the intrinsic evaluation. So you can see them on the screen for both skipgram and SIBO model. We also shown that our model has visibly better performance on the intrinsic tests. And even if you just run the word analogy task, you can see it for yourself. The words that returned by the model is visibly better and looks more natural choices, more natural choices. But this doesn't correlate much with the extrinsic evaluation results. Also, we've shown that there are some correlation between the hyperparameters and the results of the extrinsic tests, but has no significant impact on the corresponding metrics. If we sum up the contributions that we made in this paper, we basically conducted the first study of effects of various hyperparameters for FastText word embeddings in the Ukrainian language. And probably given the size of the experiments that we did, is probably the biggest experiment of such kind in any language. We also created and publicly published the largest collection of pre-trained Ukrainian word embeddings. They are available on the Hugging Face, both for SIBO and skipgrams. We presented the optimized model, which outperforms on intrinsic evaluation the models which are available in the wild. We presented a new word analogy dataset for Ukrainian and provided the first formal analysis for the Ukrainian word vectors using intrinsic and extrinsic approaches. And here I would like to thank you all, and thank you all for listening, and thank you all the people who helped us with this work. Thank you, Nataliia.
Thank you. Bye.